To FMA 0134 Mathematics 3. Today we're going to learn chapter 1 linear programming. In this linear programming, we're going to cover system of linear inequality consists of only two variable. Why is only two variable? Because the graphical method only support two variable x and y. Okay, if you have a three variable, that means you need to draw a 3D diagram. That is impossible for manually sketching. Okay, and then after that you need to identify where is your feasible region. Then you're going to interpret the problems and then you solve it. Okay, so now, why linear programming is a very important topic, a lot of problems in the real world you can formulate it as a linear programs, and then you will be having exist efficient methods to solve them, or at least you are going to give a good approximation. Okay, so when the linear programmings are developed, actually they are developed during World War II. Why? Because in during World War II, the material are limited, so you need to have a plan. If not, then your supply is going to be have a shortage. Okay, so actually what from there the programming terms, why we just thinking programming, why is programming? Actually programming was a military term that referred to an activity such as planning, schedule, and so on. Okay, and who is the one who developed it? Actually is this person, George, an US Air Force. Okay, he developed simplex method during 1947. Okay, you are not going to learn a simplex method. Only the student who going to take OR or operation research during the degree time, you're going to see the simplex method again. Okay, so in real life application, you have more than these four. Okay, but the thing is normally is during the transportation. For example, okay, if you want to send the gardenia brake, okay, to any factory, any places, such as from the factory going to send it to the shop, okay, you need to plan well. If not, you're going to have a shortage. Or then in the factory, we want to minimize the product cost so that we can maximize our profit. Or the new trend is like a diet problem. So that's mean like your breakfast. Okay, your breakfast, let's say you need to have an 420 calories. So all the vitamins and so on, all the minerals. Okay, and then you need to have a limit the fat and so on. So that's mean you need to plan well. Okay, and then in linear programming we have a few standard form. Okay, so this is the one we are going to use. Okay, so normally we use Z to represent our objective function. Okay, why is Z? I don't know, but the thing is normally, okay, not only Z, sometimes we use P stand for profit and so on. Okay, and normally you must include either is maximize or minimize it. Okay, and it's quite linear that you can use max or you can use min, doesn't matter. And this is all the constraint. Okay, and the problem is a maximize or minimize. Okay, all constraints are inequalities. Okay, not equation. Okay, so inequality means that is greater or less than or equal or greater than or less than. Okay, so and because of most of the linear programming problems are involving items. Okay, so it is impossible it is negative, so that's why it said that all variables are non-negative, but there are cases that it can be negative. Okay, so the one variable is controlling everything, we call it as a decision variables. Either you want to use x1 x2, you can use x, you can use y, you can use a, you can use b, you can use p, or you can use q. Okay, and the one you want to maximize or minimize, we call it as an objective function, and then are subject to the constraint. Okay, as we said that it will be inequalities, and normally you yourself have to include the non-negative, especially involving items. Okay, so In linear programming, is all the objective function plus the constraint are all linear. Okay, if you see over here, it's only two variables and only all the linear thing. Okay, if let's say here have a power of 2 or you have an xy, it's not called linear. Okay, then after that, so what is called what else? The constraint of a linear program define a zone of solution. Okay, so let's say you have the feasible, okay, or the uh, inequality bounded. Okay, then after that you have one thing is all bounded here. This is called zone of solution. This zone of solution we call it as an feasible region. So what is the official definition of feasible region? It's called the set of a points that satisfies all constraint. Okay, okay, it must be satisfy all the constraint. Okay, and if satisfy all the constraint, basically you can choose them to fit into your objective function. Okay, during your SPM you are not learning about corner points property. Now we are learning about corner points property, and optimal solution must lie at one or more corners. Okay, so this property telling you that your solution must lie at one of the corners. Okay, it cannot be lying in the middle. Okay, it cannot be lying in the middle or close to it and so on. Okay, and what is called optimal solution? From all the corner points, okay, that is your candidate. You choose which one is going to fit into your objective function. Okay, then over here there are a few situations in linear programming. The first one, redundant constraint. Okay, so although I give you two different constraints, x1 less than 10 and x2 less than 12, okay, so basically this one, if you see that here is only if you only give me x1 less than 10 is sufficient enough. No need to give me the x1 less than 12. Okay, then the second one is in infeasibility. Okay, although I give you two, but if you can see that they are not overlapping, when there is no overlapping, means that there is no solution. Okay, then after that, okay, this is the cases we don't like it to happen is alternate optimal solution where there is more than one optimal solution. If you look at it, this line 2t plus 2c equals to 20, actually this one is the is an objective function line, and this overlapping making you having one straight line that they are overlapping. So you have one straight line of the solution. That's when you have more than one solution. And the last one here is called unbounded solution. Okay, unbounded solution means that if you look at it, this shaded part is going to infinity. Okay, so if you say that looking for the maximum, you never know that when this graph is this shaded part is going to end. Okay, so that's mean you basically you also have no solution. Okay, but unless it is asking for minimum, so you're going to look for these two corner points. Okay, now what is the difference between now and your SPM? During SPM you draw. Okay, the keyword here is you draw on a graph paper. Now you're going to sketch. Sketch, what is the difference between sketching and the drawing? Okay, sketching you no need so precise. Okay, drawing means that you calculated box by box, but this one sketching, if you well enough, you just use the true ruler. You use the ruler to draw two line, and if you good enough, actually you just having drawing the same equal length is enough. Okay, not necessarily need to measure. Then after that, after you have the feasible region, okay, so we are only the same. We still need to draw all the constraint. After that, we also need to identify the feasible region. But now, during your SPM, because you already plotting in the graph, what you need to do, you draw an objective function line. You move your, okay, Last time you move the line up and down to find your objective. Okay, so normally we'll be going to the upmost or you're going to the downmost. But now during your Asasi time, what you will do that you from this visible region, you attack only all the corner points. You find all the corner points and you evaluated them. Okay, so the first one, we recall what is during SPM. This is also applicable now. That is, when you have y greater than x, so is and greater, don't have an equal. If y no more than x, so y is less than equal than x. This is the thing you learn during SPM, so it's still doing the same thing. This is something new to you, that is, okay, how do you know is any points belongs to the equations? Okay, any points belongs to equation or inequality. If I give you you have an equation, let's say x plus y equals to 2, and I give you x equals to 2, y equals to 3. So, and I ask you, is it 2, 3 belongs to this equation? What you will do, you just take the 2, substitute here, plus 3, and you know that it is 5, and it is not equals to 2. So you are going to tell me 2, 3 is not belongs to x plus 2 equals, x plus y equals to 2. So happen to the inequality also the same. The only different thing that is, you need to check the inequality sign. Okay, so let's us try the first one, 3, 5. Okay, so I have an equation 1, 2x plus y less than 6, x minus 1 greater and equal to 3. So I just take this one, substitute to 2, 3 plus 5, actually it is equals to 11. It is not less than 6, so I really can tell you this Q1 is not fit into this system of inequality. So like Q2 we can try. Okay, so I still moving from the equation 1. 2 times 6 plus 0 equals to 12, also not less than 6. So I also can tell you Q2 not belongs to this system of inequality. Now we try Q3. So 2 times 3 minus 2 equals to 4. It is less than 6, is true. Then secondly, I have to substitute this one into here. So 2 minus 2 is equals to 4. It is greater than 3, so it's true. So Q3 is fit into these two inequalities, okay? And the last Q4 here, I have 2 times 0 plus 0. Is it less than 6? Correct. But is it 0 minus 0 greater than 3? Is 4. So Q4 also not located in this system of inequalities. Okay.